Good evening. I want to welcome you to the car clinic up in Mahopac, New York. Also home of TST. With me tonight is Craig Truglia, Rich Peterson, and of course someone that you're more than familiar with, Mr. Jerry Truglia.
Thanks, Pete.
Tonight's topic is voltage drop testing. Before we get started, just let me share a few little tidbits with you. Again, we want to appreciate you taking the time to join Motor Age and TST for this first of 4 webcasts that we'll be doing over the course of 2011. As I said, I'm the technical editor for Motor Age, but I really want all you guys to know that for 35 years I did what you guys are doing right now, working under the hood of a car, supporting a family. And this is one step Motor Age is taking with the help of TST to make sure that you have the information and resources you need to do the job that you're trying to do and take care of those families. If we get the next slide, please. One of those tools that I want to make you very familiar with is our Motor Age online community at motorage.com. When you log in to motorage.com, this is the site you'll see. A few things I want to point out to you. First, if you like the Motor Age print edition, you're going to like the online edition even more. It's called Motor Age How To. Every month, the new edition is posted right here to the site, easy for you to find, or you can subscribe to it, have it delivered directly to your inbox. We also offer a variety of newsletters that are tailored just for you, not wasting your time with a bunch of sales pitches and newsletters. Try to give you information that will make, again, your life a lot easier in the bays.
And let's not forget, Pete, Got Pete. The Got Pete is going to give you some good information on the Motor Age website.
Absolutely. In fact, when you click on that link, you'll see my personal profile. I encourage you to set up a profile of your own, friend me, and you'll be able to stay in touch with everything that's happening day to day. Last, here's where you go to join the community and keep up with what's happening in the world. Can I have your next slide, please? One thing I do want to let you know, it's going to be really hard to give you a complete rundown on the intricacies of voltage drop testing. If we can accomplish anything tonight for you, is to help you understand the basics and fundamentals of this very important diagnostic technique. Tomorrow morning, there'll be a blog posted on what we covered tonight with a lot more info and resources for you to use. We'll also set up a topic on our message boards in our online community for your comments, any questions that perhaps we don't get to this evening. And I want you to take the time, please, to tell us what you liked about tonight's presentation, what you didn't like, and the topics that you would like to see covered in the future. Last but not least, if you want to see this again, we're going to make sure it's available for you to view as many times as you like, whenever you like.
Let's also say, Pete, that at any time during the webcast, they could ask us questions so they know exactly what we're doing, so they could ask the questions.
Oh, absolutely, and we encourage you to ask any questions that you want, and we'll try to cover as many of them as we possibly can in the time we have tonight. And that's what you see here and what we're going to cover. We've just about taken care of the introduction. We'll talk a little bit about the fundamentals, answer questions as we go along, then actually perform the voltage drop test to show you how the meter does the math and when it says ouch, and use the voltage drop to actually fix a few cars. We've got a guinea pig set up all ready to go, so why don't we just dive right into it.
Okay. So we're going to do the board or the car first?
I think we'll do the board first.
Yeah. So let's move this over. I'm going to give Pete a hand here to move this over.
Okay. We see that all right, fellas? All right. I want to share a little story with you. Several years ago, I worked for a company that sponsored technician skills competitions, and I got to go to the Nationals, which was a pretty neat thing for me at the time. When I got there, the challenge was a GM truck with a mass sensor code for a circuit range performance issue. This test would have found that problem in a matter of minutes, and I thought I knew how to do it. I knew where to put the leads, but you know what? I didn't understand what the meter was trying to tell me. And from conversations that I've had with G and other TST members, that's the heart of the matter. A lot of you guys know where to put the leads. It's what the meter readings are trying to tell you that tends to throw you off. And here's what I did, and here's what I encourage you to do. Take a battery or jump box, some wiring, and a bulb, and start playing with this. Let's try it. Simple circuit, right? We've got a load, a source, and a path to connect the two. That's what you need for a simple circuit. Now, of course, the car is going to add a control device to turn that circuit on and off, and some type of circuit protection device, whether it's a fuse, a circuit breaker, or a fusible link to protect the wiring in case something shorts. Here's the next thing I want you to do when you've got your little simple circuit. Take your multimeter. We're going to measure first at the source, so we know that our meter's working well.
And we got 12 volts, 50 millivolts.
The next thing I'm going to do is go all the way down. You got the top point?
Yep, I got that.
We'll go to the positive side of the load. See what I got.
12 volts, 30 millivolts.
So we have about the same reading. The voltage is there to overcome the resistance in this bulb, to push the electrons through it, if you will. Let's see what we have on the other side of that load once that work is done.
And let's not forget, Pete, this other side of this circuit, this ground side, is very, very important, as you'll see in a minute. So we have, what are we reading? 26.3 millivolts voltage drop, which means almost all of the 12 plus volts was dropped with this load, the light bulb in this case.
Yep. And that, fellas, essentially is what voltage drop is all about. Now, a lot of times you run into situations where there's a thief in that circuit. Anytime I add resistance to a simple circuit, it's going to want its fair share of the voltage. Let's demonstrate that. Let's just add another bulb.
Now what happened? Oop. Besides me knocking the clip off. Okay, what happened to our lights? They got dim. Why? Because you understand we're in a series circuit. We got more resistance in there. The bulbs got dimmer. Now let's do a voltage drop test again on this, Pete.
Absolutely.
And see what we got.
Another thing that's interesting to note is that all the available voltage will be used by all the resistance in the circuit, and it will be used in proportion to that resistance. Now these bulbs are the same. That's why you see them burning about the same intensity. If we change the bulbs with different resistance values, you'd see that difference as well. We'll start then with our reference to ground. Take our meter, 12 volts, 100 millivolts.
Yep.
Next step will come all the way to the positive side as we did to begin with. 12 volts, 80 millivolts. So that's about the same. You know what, gee, that must mean this side of the circuit's just fine. No thief there.
No thief.
Let's go to the ground side.
Whoa,
Wow, look at that. Meter's now reading 6 volts, 140 millivolts. A lot more than the first time around, huh guys? That right there is the red flag. That's the meter telling you there's a thief in the mix, and he's between where my meter lead is at the load and between where the meter lead is at the source.
Let's say, Pete, that this other bulb didn't exist. Let's take this out of the way for a minute, and you have a light bulb on a vehicle or some sort of motor or blower that's not working correctly. Well, you could have unwanted resistance in the ground side. This bulb is more resistance, isn't it?
Sure.
So what's happening, we're losing something here on the ground side. You know, how many times we drive down the road and the headlights dim on someone's vehicle? 9 out of 10 times, it's the ground side,
Right.
not the feed side.
And if you think about it, that makes a lot of sense. All the feed sides in the car are pretty much directly wired between the source and the load. But the ground, the entire ground is the car, the body of the car is used as a ground point. And you've seen that. Ground's connected to the fender wells, ground's connected to the sheet metal in the trunk, the whole car. So there's all kinds of places that it can go back.
We have a very good question from the audience. What's acceptable voltage drop between electrical connections for the feed and the ground side, positive and negative? What's the spec?
You know, that's a very good question. And you know what? There isn't just one spec. Rule of thumb, for general circuits like a lighting circuit, I use 1/2 volt. But that's dependent on keeping one lead set at the source, at the battery, and the other as close to the load as you can get, so you're testing the entire circuit path. What that means, guys and gals, is that if you have a problem in the rear of the car, you need a jumper lead that will reach all the way up to the battery and back to your meter to test the entire circuit path.
And we would do that, Pete, we use it on a power probe that will show you on the car in a little bit, so you can have that good lead going all the way to the back. And remember, you know, like Pete said, 500 millivolts, some manufacturers recommend that. Some may be as low on a non-computer circuit as 200 millivolts.
Right.
A computer circuit, 100 millivolts or less, because think about an oxygen sensor, 1,000 millivolts. Take 100 away on the feed side, take 100 away on the ground side, and what are you going to have left? 800 millivolts to work with. Something won't work right.
Right. In addition, on the high side of that is a starter circuit, where there's a lot of amperage draw, and you can get away with a volt or so.
Exactly, exactly. So it does depend, and I think we kind of answered that. Does he have any other questions, Craig?
No, that is it for now.
Well, thank you for the question.
Thanks for the question.
Don't be afraid to ask. Remember, we want your questions so we can help you understand this better.
Right. So let's go back to where we were. When we checked the feed side of this circuit, the voltage reaching the bulb was pretty much the same as what we started with at the source, telling us that that side of the circuit was okay. Now we're on the ground side. If voltage drop worked the way it's supposed to, that bulb would have used all of it up. Instead, I'm still reading almost half the voltage supply left. That means there's a thief in the mix. And here's how you find him. Start working back towards the battery, moving your lead at convenient points in the harness until your meter lead returns to normal. When you've done that, you know that the source of the problem is between that test point and the last. And then it's a matter of narrowing it down from there. Let's show you. Let's just move to our thief. Still reading the same amount of voltage drop.
So not much between those two loads.
Yep, so the problem doesn't lie between those two test points. Move to the next one. Wow. Now we've dropped down to
56 or so millivolts.
That's normal. I know now the problem is between those 2 points.
Now, in this case, obviously, this is the way this circuit would work. There's really not a problem here. Why? Because we're splitting this. The 12 volts is being split between two equal loads that have the same exact resistance. That's what Pete said before. We have two exact light bulbs with the same resistance.
Right. So if there's a difference between the resistance, and let's just say in the real world that's going to be a worn or damaged connection, a corroded connection, a loose ground to the body or engine, these are where those variances are going to come into play. The key factor I want you guys and gals to get is that when I got to the negative side and I tested the negative side of the load, instead of having something of 0.5 or less, I had a significant reading. The meter was throwing up a big red flag saying, hey, this is the side the problem was on. Now just for giggles, let's move that thief to the positive side.
While we're doing that, someone asked, does dielectric grease really promote a good connection and lower resistance?
Actually, dielectric grease is an insulator. If you want to do something that will help electrical contacts, and I think G will probably agree with me,
Stable 22.
Stable 22 is an excellent product to use.
Yep, you could buy that CE1 Napa SL5 CarQuest. And Stable 22 is a real good cleaner and makes the conductivity quite good.
Now I know it's going to kind of look the same from your viewpoint, since I just moved the bulbs around, but remember this is my primary load that I'm testing. I moved my little bitty thief over to the positive side. So if I'm going straight to the load after checking the source voltage, here I'm reading about 6 volts, maybe a little bit less. Again, this should read about the same as the battery on the positive side. Since it doesn't, it tells me that the problem is now on the positive side of the feed side of the circuit.
And remember, take this out of the picture, that bulb. We're making believe that bulb is resistance in the circuit on the feed side.
Right.
So again, forget about the bulb. This is how you would check voltage drop on the feed side. Some of this may seem very basic, and we got a little more here before we get on to real car stuff, but it is very important. It's like building a house. The foundation is the key. Having been doing this training for years, and Pete's been in the business for years, and Rich is an electrical expert. Guess what? We find that more cars get fixed by voltage drop problems than any other problem. People think they know how to check it. They buy an expensive meter and they use it for one function. It becomes a glorified test light. You need to know about VD, voltage drop. Okay? You should know voltage drop inside out, and that's what we're showing you here. So we're going to continue on. Don't think this is the only thing we're going to show you. We're going to show you a lot more on a car and explain a lot more.
Sure. And right before we go in, before we start talking a little bit about some fundamentals and then go to the car, there's one other thing I want to share with you. Don't want to confuse you, so I want you to pay close attention to this. Remember the ground side? And we had a reading of 0.5 volt or less to tell us when it was good. And if there was anything more than that, it told us it was bad. Well, the ground side was referenced because my meter lead was on the ground side of the load and the negative side of the source. Here on this side, I actually had to do some mental math, didn't I? I had to subtract what the battery started with and what I read at the positive side in order to come up with what the actual voltage drop was. Well, why do that? Let's let the meter do the math for me. If I want to check the positive side of the circuit, now I'm only going to fudge a little bit. I'm going to set my range here to millivolts real quick. I think we got that correct. And now I'm going to measure straight between the positive side and the positive side of my load. Holy crap, it's going OL. Maybe I shouldn't have said that. Didn't hear any beeps in the background, did you? Beep, beep. This is something that we found out when we were playing with this today. Most meters limit on the millivolt scale is 400 to 600 millivolts. Well, gee, that sounds a whole lot like close to 0.5 volt, doesn't it, Jay?
Yep, and that's the voltage drop threshold in a lot of cases.
So if I go to either side, positive to positive, negative to negative, and I get a reading like this,
you know you got a problem.
ouch.
Ouch. So, yep.
Any questions on the basic procedure that we can answer, or you'd like to see re-demonstrated real quick?
And Pete, I'd like to say one other thing. You know,
Sure.
Pete had the negative leave here to the positive, which doesn't matter on a digital voltometer. You could go positive here and then go to the load and get the same reading. The only difference is your meter is not, in this case, not going to show you a negative number if you were getting a reading. The other way, sometimes it'll show a negative number, but it doesn't matter.
Right.
I usually teach, just so people kind of get the idea down, positive to the most positive, which would be the positive battery terminal, negative to the positive of the load. But it doesn't matter, ladies and gentlemen. It doesn't matter which way you really do it. Just something to maybe make it less confusing in the future. Positive to the most positive, negative to the next. Craig, do we have any questions from anyone out there?
None right now that
Okay.
immediately relevant.
Very good.
I also want to point out something here. We looked at voltage and voltage drop, and as we said earlier, voltage is that force that gets the electrons moving, pushes them through the resistance of the circuit. And once that's used, it drops or it's done. One thing though, there's a very valuable testing tool we're going to just kind of put into play here is current. Current's a little different. I can come up here with the two bulbs in series and measure the current with this inductive clamp or with my meter or with the low probe. I'm getting a reading of 1.38 amps through the circuit at this time. Now, if I'm trying to diagnose if there's a problem, current can be attached anywhere that's convenient for me. I don't have to get right next to the load. I don't have to pull harnesses apart. Let me demonstrate. Now I'll go all the way to the other side and clamp around the negative lead. Same reading. So current can be a very valuable tool, but this is a real good demonstration. Shows you that no matter anywhere in the circuit, current flow is going to be the same.
And here's another good point. Let's leave it on there for a second, people. Let's leave it on there a second. What happens if we try checking current and we have an open? We have no current flow with an open, okay? Or a severe voltage drop if current is way under the specified amount of what you would think that load is.
Oh, you mean if I took this beef out of the mix, we might get a different reading?
You bet. So you can see as you change, you get different readings. There's our current is a lot higher, okay? As we add resistance, so let's say we were working on this particular bulb or motor and we knew, hey, it pulls about 2 amps. How many use current ramp fuel pumps out there? right? But let's say you're working on a fuel pump that pulls 5 amps normally. Well, you go on there and you're only pulling 3. Well, could be a problem with the pump, but it could be resistance in the circuit. Resistance in the circuit equals voltage drop. So there's our VD, once again, voltage drop, that can rob our current and make our motor run slower or our bulb go dimmer. But remember, if you have no current flow, you have an open circuit somewhere. It's a quick test, okay? So sometimes these little ammeters, Pete, they can come in quite handy, as you know.
Absolutely.
So you want to hook up the rest of the bulbs here?
Yeah, because I think it's interesting where oftentimes a mistake can be made assuming that there's a problem with an open when there may not be. Okay, with 2 bulbs, it's easy to see that they get dimmer. If we keep adding sources of resistance, no, I'll wait to the end there. Or we already,
No, you're already hooked up.
We don't need that.
well, you can see that, but look at the difference as we continue to add resistance.
Could they see that, Rich?
Hold on. Yeah.
These bulbs are very, very dim. And current is going to be what in the circuit? Going to be the same everywhere. Let's check that current.
Well, gosh, you know what? That kind of reminds me too, G. Don't always do the math, but Ohm's Law tells you about the relationship between voltage, current, and resistance. We have the same voltage. We have a lot of resistance. What do you guys think is going to happen to current?
Yeah, let's give them a second, Pete, to say what they think is going to happen to current. Now remember, our bulbs are dimly lit all the way here. Every single bulb has the same resistance, and they're very, very dimly lit. So what happens to current with a lot of resistance?
They say it goes down.
Excellent, and let's check it.
Remember, I can check this anywhere I want.
And Pete, it's going to be the same in the circuit, isn't it?
Everywhere in the circuit. And you know what? How about 0.7 of an amp? So yep, it sure did go down. Now, I'm just wondering, G, if you got a problem with the fuel delivery, and the circuit, just like you see here on the board, it's intact. There's no holes, there's no opens. But a bad ground on maybe the fuel pump circuit
It can do it.
could make that pump spin a lot slower.
You bet. And we got a good example coming up as well.
Sure.
That we'll be talking about that, you know, happened to me on a vehicle that was brought in. And thinking about how a circuit works, where the current flow should normally be, you can diagnose this problem.
Yeah.
Okay? So we'll look at that in a minute. What's going to happen here, Pete, if we use our wire and we connect here?
Well, let's see. We'll bypass some of that voltage drop.
Okay, so let's go 1, 2, 3, 4, 5 loads and go right here. Hey, we got brighter, didn't we?
Must be less resistance in the circuit.
Less resistance. What do you think happened to current flow?
I don't know, guys. What do you think happened to current flow?
Up.
Went up, huh? Well, let's see.
Let's double check it. And again, you could do this, you know, we have one of our TST board members, Pierre Rispo, who donated all these light bulbs. I soldered all this stuff up, you know, made some clamps for it. So you could see something simple that you could make. You all got a whole bunch of light sockets and, you know, light bulbs hanging around that you haven't used. This way you can get the feel for it. We'd also like to say, you know, they can go to a place like Radio Shack to buy one of these little kits that I use in the training class, just to get people to think about how electricity really works. And on those kits, you won't burn your meter fuse out, even if you're doing amperage in series, because it's a low amperage circuit.
Yeah. So we did have an increase in current, as everybody predicted, and I just want to kind of stress again what G just said. Guys and gals, I was mad when I lost that contest over something that should have been relatively simple. This is what I did to understand what voltage drop testing does, and I kept at it until it clicked. And I'm encouraging all of you to do exactly the same thing. Tomorrow in the shop, make you up a simple circuit, pull out your meter. This should be archived within the site within 48 hours. View it as many times as you want until you make it your own. When you do, you're going to start finding things faster and easier than you ever have. And G, I tell you what, I want you to share that story now with them about that bad ground that you were telling me about. And then we'll get to the car and we'll show you just how easy this can be to work.
Yep, because voltage drop, again, is so important. Let's look at what I had encountered here. This is a problem car that came in, a different car here, but it was one of the same type of cars that came in. This is when I was doing a class up in Massachusetts, but It's a problem car that came right here to the training center. The vehicle complaint was, when I come to a stop, it runs poorly, and when I'm on rough roads, Pete, it runs poorly, okay? So what's going to make it run poorly? Let's move on to the next slide, Craig. Okay, one of the things I want you to notice, the most important tools you have is your eyes, your brains, your ears, your hands, and your nose. Well, here, I don't have to use my big nose, I got to use my eyeballs. And my eyeballs tell me the lights are kind of dim. What we have here is a scope inside the car, and you don't have to learn how to read a scope. Watch what we're going to show you. This line right here, this yellow line, notice the silver bar. There's the yellow line. Look at it carefully. Notice the line is close to the silver bar and the lights are off. Let's go to the next slide, Craig. Notice here, the lights are bright. There's that same bar, right? Look where the yellow line is. Current is up, okay? Current is up higher and my lights are working. Let's click to the next slide, Craig.
Just one real quick interjection there, Gene. Guys, you don't need a scope. I mean, if you have one, you use it, that's wonderful. It's a wonderful piece of diagnostic equipment. But you can do exactly the same thing with your meter, with a clamp around amp probe, or one that's dedicated for use with your meter. So there's a lot of different avenues. But I think what Gene and I do want to stress to you, current can also be a very valuable diagnostic tool.
Correct. And, of course, we are limited on time tonight. It's a whole class just on using your amp clamp on your meter, because many people get confused with that, Pete. So we're using just a handheld tonight. The scope here is a visual representation. Now here's the two of them. Broken car. Okay, car runs but doesn't run good. Lights are really dim. You can barely see them. Amperage is low. Okay. Lights bright. Amperage is high. Okay. Let's click on. Now, what would make the car run lousy? Remember, complaint, rough running, okay? Anything on rough roads. Now, when this car came right in the back here behind us, I went out there, I started this vehicle up, and Pete, it started up, it had high idle, it was in February like now, cold up here, not like your warm weather in Florida, and I noticed that the car sounded normal. It had high idle, went down.
Yeah, I hate it when that happens.
I walked all around the car and I said, this guy's crazy. A technician student had dropped this car off, and I thought he was crazy. But as soon as I got in the car, I put my foot on the brake, Pete. When I put my foot on the brake, the car ran lousy. I had to pull it up to the bay door. As soon as I let my foot off the brake, it was going good. Stopped for the door, put it in park, got out, car ran good again. Touched the brake, ran lousy. So I said, what in the world is going to cause this?
Well, Mike, you're stepping on the brake, and the car's
I'm stepping on the brake. Now, the shop had replaced, the other shop had replaced computer, fuel pump,
wow,
wires, they did a whole bunch of stuff. Module, this was a GM vehicle, they went for a lot of bucks on this. But let's look at this carefully. I said, what's going to make this do this? Well, when I looked, something had to be in common here. We got this G402. 402 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 or so different loads. Let's go to the next slide. Now, what else is connected? Now, if I was driving to Florida to go see Pete on a vacation, which I desperately need, okay, what I would do, especially this time of year, I would want to look at a wiring diagram. It's the map. Well, looky here. The fuel pump is what? G402. Same circuit. Now what I did, and I don't have that here, looking at the fuel pump, I actually saw the wave going like this, perfect, nice hump, straight across, because the relays are right under the hood. I put it on there. When my foot was off the brake, it was high. As soon as I went on the brake, it went low.
Wait, no, let me understand, Jay. You said the current went low.
Current went low.
Well, guys, if the current went low when he stepped on the brake, what changed in the circuit? I mean, the car's running, so the source voltage must be the same. What changed?
Do we have any answers there, Craig?
Resistance problem. Resistance went up.
Absolutely.
Resistance
really
went up.
Good.
Very good. Current went down.
And just as a real quick side note, most of you guys should have gotten an email for a PDF download that will give you some resources that will help make voltage drop even easier for you to understand. on how to read the schematic, how to use the meter, electrical fundamentals. If you haven't gotten that, it will also be available for you on the motorage.com website. Download it, read it, use it.
Definitely. Very good. Let's go to the next slide, Craig. Now, where the problem was is in the original car that was here. This is just another car to show you where the ground is. Notice no stall washer there. The original one, the car that came right in here, the stall washer and bolt from the factory was right here. This is the fender well. Now, this is New York. We use salt here in New York, Pete. A little different than Florida. Orange and tangerines down there in sunshine.
The only way to get corrosion is to drive through the beach, buddy.
That's right. Well, here we have corrosion all the time in the winter and other places in the country as well. So what happened, this rusted out. The ground, when we had our foot on the brake and those loads started coming on, those light bulbs, like we seen there, what happened? The amperage dropped down, so the vehicle would not work right, okay? What I did, just like here, is move this to a good ground. Put a connector, clean it up. The stall washer, you know the thing you drop and go, can't see it from where I live? You need to see it. Why? That stall washer digs in the metal to give us more contact area. That little sheet metal screw, and by the way, if you're using your air ratchet and you go, burp, oops, went a little too far, Pete. Then what happens? The threads, you stripped it, and it's not going to last long. Also, painted surface. You need to clean up a little bit of painted surface, correct?
Yeah.
Now, there was still one part left, Pete. What about the bumpy roads? Well, the bumpy roads, this is where the eyes and the brain, you know, comes into contact again. I looked at the brake pedal. The guy must have wore work boots who owned the car, and he pivoted. There was a pivot mark in the rug, and the pedal, he must have hit the end of the brake pedal where the pedal was worn on the rubber on one side. So all I had to do was go like this, and the lights would come on in the back. I adjusted everything up. The car was fixed and out the door for what? Locating the ground to somewhere different.
Right.
That, my friends, is voltage drop. Does everyone understand that? Craig, do we have any questions or comments on this voltage drop?
Not presently.
Okay,
Just
now,
real quick, I want to make a comment too on what G was saying. Number one, the area where the bolt corroded caused a loss of ground. That's what we talked about earlier. The whole chassis of the car is used as a grounding point for electrical circuits. So anything like that can cause that problem. When that ground path got weak and added loads were placed into it, it could not handle the current load. And then we had a problem. Here's a really good way of thinking about it. Starter cable. Nice big fat piece of cable, right? If I take an ohm meter and I measure the resistance across the two ends, it's going to give me a very low reading, probably under an ohm.
sure. Big thing.
Now, what if I took one strand of that same cable out? What do you think the resistance would be on the one strand, guys?
Any takers there, Craig? Okay.
About the same.
About the same. Very good. So
But-
we got some people awake out there.
But, would you try to start that car with one strand of wire connecting the starter motor to the battery?
Maybe if you wanted a little smoke shot.
It wouldn't last real long, would it?
No, it wouldn't.
That's why a normal resistance test with your ohm meter is not always going to find these problems. Doing it dynamically, using voltage drop, with the circuit working, is going to make these guys stand out where you can find them and catch them a lot faster.
And you know, Pete, you bring a great point up. With the circuit loaded, do not do a voltage drop on a circuit that is not on. The light bulbs are not on. The headlights, the wiper motor, whatever. You need to load the circuit.
Current must be flowing.
Current must be
voltage
flowing.
to work.
Now here's a great graphic from my buddy Ralph Birnbaum that we threw in our book. Voltage drop review, so you understand VD. Voltage drops, loose connections. Oh, we get a lot of those on cars. Corroded connections. Oh, up here, tons of corroded connections. Undersized cable. You see sometimes when people cut a wire out, they may put something else. Broken cable strands. All equal low voltage, low current at the loads, meaning that load is not going to work as designed.
Absolutely.
Okay? And I want to say here, this broken strands. You know, I don't know if it was an article that you did. I think it was. Where you had a back probe pin for a wire that was all rusted. Okay?
Yes.
Now, a lot of times people pierce wires. Now, I know some of my friends that live out in dry Arizona, they can play that game. Most of the country, you can't do that. Never pierce a wire because you can break strands. When we show you something over here, we've back probed something. Very, very important. So again, real quick review, voltage drop, loose connections, corroded connections, undersized cable, broken cable strands, all equal low voltage and low current at the lobes.
We have a question. Someone says when checking a component in the circuit, he's looking for a low reading, but sometimes he's not sure whether he has just a no meter connection or the component's really good. So what should he really be looking for?
Well, one of the things I would recommend, like we're going to do on this car here, I would recommend always make sure you got a good ground. You know, on cars, Pete, when we go over to the car, I like using the power probe, and I'm going to tell you, not a commercial for power probe at all. When you put this to power and ground, like we're going to do on this battery, we're going to check to see if we have a good ground. Most of the time when you're under the hood of a vehicle or under the car itself, you may think that you have a good ground. Now, this is always ground. The meter here has power. It also has ground. Now, here's what I like doing, Pete. Because up here in the rust belt, I don't like scraping under the frame of the car to see if I got a good ground. And this is probably that gentleman's problem or that person's problem. I take my ground lead and I press. This has about an 8 amp circuit breaker in the power probe. If I got a good ground, you hear it beep. Now notice I have no red light that comes on. Why? This was ground going to power. It blew my circuit protection. Okay?
You just simulated a direct short to ground.
You bet. A direct short to ground. Low resistance, high amperage, blow the breaker. Now, I reset this so I now have power. But you see this? This becomes my meter lead ground, so wherever I am under the car, I know I have a good ground.
Yeah.
That is super important, especially doing voltage drops on a vehicle.
Two really common mistakes that I see quite a bit of. Number one, understanding what the meter readings are trying to tell you. And I think that we've given you the foundation to clarify that. Number two, not testing the entire circuit path. If you're troubleshooting a problem in the back of the car, the power probe is one excellent way, as is making your own meter lead, to always reference back up to the source, all the way back up to the battery. Check the whole path.
That is important. Checking that path is super important. Being at the main source. Remember, there's no ground on the car without the battery. You know, this is no lie. I've gone into shops where a guy has a battery on the ground, puts his meter lead there, tested, he has negative and positive, then he's trying to work on the car. It's not in the vehicle. You can't do that. Use a power probe. Questions, Greg?
Two quick questions before we move on. So is a bed of nails preferable to a larger spike that pierced the wire? And can you use a meter with the power probe?
Yes, well, let me get the bed of nails. I don't like any bed of nails because there's still a chance, and Pete can answer this on his own, there's still a chance that you can break a strand of wire. At least what you're going to do is make moisture get in that wire that is all just chewed up. So I don't like a bed of nails. I say use a back probe pin. You could buy T-pins at anywhere from Staples, Office Max, Joann's Fabrics, whatever. Okay, T-pins are the way to go, and go in carefully through the weather pack. Never ever pierce it. Your preference?
My first preference is back probing as well. I do want to encourage you that when you put in the back probe in the connector that you're very careful, because on some connectors it is possible to start in socket A and kind of veer off to one side or the other to socket B. So you want to make sure that you're going in straight. If you do find it absolutely necessary to pierce, then I like the J-hook style piercing tools, but seal it when you're done. And this might sound silly, guys, but you gals appreciate it. Clear nail polish works really good for sealing those pierce marks.
While you're yakking a second, I want to bring something out on that. Just 1 second. So entertain them for a second.
How about the power probe and a meter? Someone asked about that.
Okay, well, the newer power probe models actually have a meter built in. It's kind of like having a voltmeter in your hand, and it's good to 1/10 of a volt. And what was the limit that we had for most circuits? 1/2 volt. This can be used for performing voltage drop tests pretty much the way it is on most circuits. Any multimeter can be used just as effectively. I've actually made up a wire about 20 feet long so that I can put one end at the negative post of the battery and reach anywhere in the car I want to. I'll admit, I do like the power probe, especially for under dash work. Those little headlights make it a lot easier to look where I'm going without having to hold a flashlight in my mouth and turning my elbows sideways, and my back ain't getting any younger.
I hear you. And you know what's nice too, Pete? The cable is pretty thick, so it's not going to wear down. Before Power Probe ever came out, I did the same thing with leads. Now here's what I like using. The nail polish does work. Do not use RTV. Liquid tape. You can get this in Home Depot, Lowe's, your parts stores, whatever. Liquid tape works real well to seal it up. The 3M vulcanizing tape, phenomenal if you're in a tight spot. Very good, and again, you could buy that from CarQuest, Napa, Joe Schmo, whoever. Very good. Here's the only thing. Now, I do own a few of these. Sometimes you back probe, you can't do it. Or, one of the other things I'd like to show the audience on air-fuel wide range sensors, be very, very careful. Some of them have a resistor that's actually in one of the pins, and if you back probe it and short it, we got a major problem. Now, if you're going to use this, you probably can't even see this. It is such a small pin, Pete.
Hold it steady.
That little pin, and you could get these through AES Wave, Carlos and George. Sell it, your suppliers. Real good stuff.
Assortments.
And I forgot what they call this, Rich. What do they actually call this? It's not a J-hook. They have a name for this.
I don't know what they
And it's very easy. You press back, you put it in the wire, and
Just a wire piercer.
it's just a little baby wire piercer that, here's how it works. Goes in, and we're in there.
Yeah.
And you cannot really see where that hole is. It's that small.
For you scope guys out there, I think one advantage to using this is if you're trying to take a running or you're going to take a test drive with your scope connected, then using some type of piercing connector is going to make sure that those leads stay in place during that operation. Otherwise, back probe. But in
Could
any
fall
case,
out.
If you're going to pierce the wire, make sure you seal it when you're done.
It's called a piercing probe. Pierre Respo had just
Well, I think there's
commented.
another name that Fluke calls it who makes that particular one. But all right, Mr. Pierre Respo, thank you for watching.
Hirschman probe, perhaps.
Maybe a Hirschman probe,
Yeah,
I think it is. Yes, I think that's the correct name. It's a good probe. Are we ready to move on to the car? Or
I think we need to start working on a car.
Damn it, I got to
A
get
couple
dirty.
of questions. Why not
Yes.
RTV? People demand they want to use RTV. Why not?
RTV has, you know, it smells like that vinegar base, okay? And what can happen with RTV, some manufacturers recommend not using it because whatever chemical is in there could go and cause some problems in the wiring.
It absorbs moisture.
And it absorbs moisture.
It uses
What causes
moisture to
corrosion?
cure. It uses moisture to
What
cure.
causes corrosion in copper? A little bit of moisture, a little bit of air.
That's right.
Yeah.
And then it starts traveling up the harness. Another point too, G, with the silicone, is that a lot of these electrical circuits, especially the computer circuits, are very low amperage. It doesn't take much to throw them off.
Oh yeah, bridge that connection and go, we're out to lunch. Okay, so what do we have here first, Pete, on the car, besides a couple of meters?
I think we got power on ground.
So we have a problem here, complaint like I had on an old Ford Explorer years back. Click, 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 no start. So one of the things we like to do, I know some of you guys still like using this thing here called a test light, okay? And the test light, I want to use it for visual effect, okay? The visual effect here is, we always baseline our tools, by the way. Because how many times I've had guys that their leads were bad, their test light bulb was blown or whatever. So we're going to make sure that we have voltage here. We don't know how much voltage exactly, we just know we have voltage.
Oh, you mean we can't use the bubble model for voltage testing?
I don't know, my bubble eyes are out. This is up east here, man. We're not in bubble land. Nothing wrong with bubble land, by the way. But at any rate, if we go to any ground on the car, like right here, I shouldn't get a light lighting up, should I? How come that's lit?
Now wait
Now-
a minute, your test light is on the ground side, and that's on the ground.
Alternator ground.
Well, let's
Motor
see.
mount ground.
If we were doing a,
Hold it.
you know,
Ground.
wow, I think I want to do it with. I think we don't do it with a meter.
I think that's a good idea, Pete, because you know why? We don't really know what the light bulb voltage is. So let's take this off. And Pete, if you'll be kind enough to hold the black lead on, and remember, I'm always going to baseline my meter, okay? So I'm going to plug that in. Rich probably can see I got 12 volts, 777 millivolts, okay? Now, let's go to the ground of the motor mount. Wow, I got 12 volts.
Now, it seems to me, G, that we were doing something similar just a few minutes ago. I've got my meter lead on the negative battery post, and I also have it on negative or ground for a whole variety of other circuits at this point in time. I may not be right at a particular load, at a particular connector, but I am in the ground path. And didn't we say something about 0.5 being the most we wanted to see?
Right. Now, we're way over 0.5, so I want to ask you out there in internet land, what do you think the problem is? And this was a real problem I had in the car, okay? And I always use this in a class because people go, how's that ground lining up? How do I have 12 volts? So Craig, do we have questions?
Is there an open on the ground side?
Whoa, so someone is paying attention. There's an open in the ground side. So one of the things we can do is you could take a set of jumper cables. This is how I got that Ford Explorer in, because I didn't want to hurt myself trying to push the vehicle in all by my lonesome. I took a ground cable, went to the battery post where Pete is at the battery, went over and grounded it right here, and guess what? Everything started up. What did I do? I made a what? A temporary ground cable. I bypassed it, and you know what I found? How many of you are familiar with the wire, the battery cable ground that is stripped going down to the chassis before it goes to the block or the starter or whatever, okay? It's stripped, the battery was gassing, and what happened is that whole cable got so corroded, okay, that one day when the person first started encountering a problem, it was, oh, that's okay, it started. When it didn't start, the click, click, click got dimmer and dimmer because the ground got totally lost. Like our tech on the internet here said, we have an open somewhere, don't we?
Mm-hmm. I think we ought to point out too.
Is it fully open or is it just very high resistance?
Well, you know, that's a really good question.
Very good question.
We know right now, based on what we learned so far, that anything over that 0.5 is a big red flag. The meter's telling us there's a problem on the ground side. We just don't know where yet. Now, if I'm not mistaken, G, on the side, you were still on the engine, right?
Yeah, right here.
Well, we got to get from the engine all the way back to where I'm at. So the next step is from the engine to the body, right at the cable he's got. So G, is there saying, what's the measurement there?
12 volts, 400 millivolts.
Well, so then from the body back to the battery, that must be up over in this end here.
Yeah.
I wonder what happens if we kind of checked in this area. Could it be where the cable connects?
By the way, Rich, remember the Volkswagens that the little terminal ends weren't clipped right? And here's the difference with that 500 millivolts voltage drop. If we had a 500 millivolt voltage drop right here, that could affect everything. We could burn something up that happens on Volkswagens and Audis.
How about those universal battery cable ends? The ones that cramp on?
Universal battery ends, getting me sick already, okay? You should not use them. They're only emergency ends.
Sure.
You really need a good piece of cable cut back to where there's no corrosion in there.
Clean copper.
Okay? Use butt connectors, crimp those things. I'm talking about a big butt connector, heat shrink them, and use a crimped end that's going to go on a battery just like they use at the factory.
Actually, we have a video made by our own Richard McCuskey, and you probably know him from the garage articles he does in the magazine.
Good man.
If you go to the motorage.com community, you'll see his video on how to properly repair a battery end.
And Rich does a great job, so check that out. Let's look at the voltage drop right here.
Hey, that's different.
Yeah, I got zero, so when I want to read zero, let's see what that really is. I go to millivolts. Wow, I got nothing going on there.
Well, if I got nothing going on, then that must mean, first of all, the meter's returning close to normal. Do you think I passed where the problem area lies? What do you guys think?
Why do we have zero now? Remember, on a voltage drop, it's on a great circuit. Do you have zero at the end of a circuit?
No, there's no
No.
such thing as a perfect world, is there?
Impossible to have zero. If you have 0, you got a what? Got an open.
Yeah, no currents flowing. So let's take a real quick look, fellas. We know that the problem lies now between where G last tested and the test point before. Think that might cause an open circuit?
And by the way, look on this car. Rich, try to get in here close. I don't know how this is going to last out here. And this happens to be a nice real Hyundai, but I do have a little concern here in this area when you have this small piece of metal coming out near a strut housing, and this wire is crimped down, and if you notice, the only thing are the threads of this bolt going through here. This is all painted surface, so I'm not really getting any good ground from here, but when I put this through, you can see the arc, hear the arc, okay?
So
and you could watch that voltage drop. Let's put that meter back on before you go all the way in. Rich, maybe one hand. I'm going to go to the same place I was before. Okay. Well, hey, I'm not reading. And, let's double check our meter. Hey, my meter read's good. He's on ground. Let's check that voltage drop over here. Well, I'm reading 1.2 millivolts voltage drop. And all he has is that little bolt going through. I'm sure if he wiggles that cable, now he's up to 15. Give it a little tap up there. Okay, so it's amazing, Pete. Those bolts there.
Those bolts are the source of the ground.
Yeah, take one out and give it a little wiggle jiggle.
Actually, if you remove the cable, you see that the surface below this is painted. It is going through the bolt to get to the ground.
Yeah. Now look at that. You see that meter going OL every once in a while, just with that one bolt. So that is the source. Remember, again, I want to stress this. It is impossible to have a 0 voltage drop. There is resistance somewhere in that circuit.
Just the wiring
Gotta
itself provides a source of resistance. The longer the wire is, the more that source of resistance will be. But in normal circuit operation, it's minimal in comparison to that taken by the load or connection.
Yeah, so we're going to tighten that up and go on to our next problem. And
In the meantime, someone asked, do you need to have current flowing to have voltage drop? If so, does the amount of voltage drop directly correlate to the amount of current flow?
That's a good question. Number one, does it look like anything was on in this car when we tested it? Well, you know what? This car's got computers. How long does it take before they go to sleep? So there are circuits alive, and that's why G got the voltage drop measurement on the ground side that he did.
And by the way, that voltage drop will change as some computers and stuff kind of go
bye-bye.
into bye-bye land. And Rich is a voltage drop expert.
The second part of that question, current, no. The source voltage, if that changes, that'll affect current flow. Remember Ohm's Law. If resistance changes, that'll affect current flow. If I could phrase it one way, voltage and resistance are the factors, current is the result.
Right.
That's correct.
Now, excuse us 1 second while we tighten this up, get a little air noise here. Now notice, my air gun didn't keep going. This is an air gun that has the right torque, so we don't have a problem with stripping the bolts out.
Now, fellas, I want to ask one quick question, because I know, G, that we're running close on time. We know we said originally we were only going to run an hour-long broadcast. We do have some pretty good stuff still to share. I know we don't have any problem hanging around a little bit. Make sure the guys out there don't mind hanging around with us.
Okay, so we don't have anyone giving us the big thumbs down. So let's continue on.
Let's go. This is
Okay.
too important.
Maybe do you want to do the little light bulb thing here first, just to kind of get that out of the way, so we don't forget the light bulb in the circuit here, to show a lot of things that people forget, kind of brings the voltage drop scenario back home. Put the red and the black to the battery. Make sure our load works real well. Take our meter. Okay, now we see this working really good here. Okay, we're going to baseline our meter. And we got 12 volts. This meter has extra display, 602 millivolts or so. Okay, Pete's going to stay on the ground. Now, here's what happens in a lot of circuits. Okay, and here's the thing that sometimes people don't understand. And of course, we got wires everywhere like I normally do. I always need wires to reel up or something or another, because I can tangle wires up with the best of them. Now, I got a question for everyone. This load is not working. Do we have any voltage going to this bulb? We're still connected the same way the circuit is, except that we have a real bad connection here, right? And one of the things that I'd like to show you is this wire, if it has no resistance in it, we should have almost the same battery voltage, right?
Absolutely.
Now the load's not working. If the filament in the bulb is good, how much should we have here on the ground then? These are basic principles, we understand that, but these are things that you need to get down in your head to be able to do a voltage drop.
And understand what that meter is trying to tell you.
Someone says 12 volts.
Very good, because sometimes we get no voltage. Again, having doing classes for many, many years, a lot of people think there's nothing there. Well, we're going to get the same voltage. Why? Nothing has been dropped. Remember, electricity is nothing more than this big circle. Here's the big circle that makes it and completes it. See? Going up, coming around. And if we have any unwanted resistance, whether it be on this side or that side, okay? If we put a resistor in here or we had corrosion in this wire, if this is not a good connection, what's going to happen? That bulb is not going to be bright as it should be. Okay?
So let's think about that for a minute, G. If on a working circuit, I should have the same going in as I did at the battery, and next to nothing coming out. If I got nothing going in, the fault must be on the positive side.
Very good. And
if I've got too much going out, it's on the negative side.
Right.
If the voltage going in and out is the same, must be an open on the ground. And if I have a perfect zero on the ground side,
you have a
bad load. And guys, we will summarize this for you again on the community site, and the video will be there for you to view as often as you wish.
Okay. I keep getting asked this. Is voltage drop different for the positive compared to the negative side of a starter circuit?
No.
No.
Because current flow is the same everywhere in the circuit.
So voltage drop would be equal. Again, 500 millivolts on a starter circuit, since we have a lot of current flow, no one's going to cry if we have a half a volt.
You could have different voltage drops on the positive or the negative side.
That's correct.
Yes.
Plus different connections, right? There's
That's
a relay
correct.
going there,
And you know what? Just as you demonstrated, you can have more than one issue, can't you? You've seen that in all types of diagnostic situations. If you find a source of voltage drop, fix it, and then do what any good tech would. Verify your repair.
Okay, so now we got a complaint. The horn don't blow. Or
Let's
it
try
doesn't
that.
blow loud. Now, Pete's first going to hit the horn, and then we're going to use Rich to go up in the car. Uh-oh.
Ooh, that sounded kind of sick.
That horn doesn't blow too good, does it?
Not really.
Okay, so what we need to do is check this out. Now, of course, doing something live, we know we only have an hour, and we're at an hour, but we're going to stay with you a little longer and explain how we're going to find this particular problem. We're going to use the power probe. Where's my power probe? Where did we put that baby?
Right here, right here.
Okay, here's the power probe. Now, why we're going to do that, because we're going to stick Rich up in the car. So again, what's the rule here? We take the power probe, we make sure we got a good ground. And that means what, guys? That's right, we got to pop the fuse. Pop the fuse, you heard the noise. No power going there, reset it. It needs a second sometimes to reset. There we go, we got power. I'm going to take my meter, and now I know I got ground on this end all the time where I can make power.
Sure. And then the
Okay.
next step of voltage drop testing, we know what we have at the battery, so now we got to get to the load. We
right.
need to test that entire path, so get as close to the load as you can. In this case, we've done some preliminary work to make sure that we can do that with a minimal amount of time wasted. We already have the horn out where we can access it easily, and you can see it.
So here we go. We're going to go up and we're going to show you we have the horn out. Remember, the horn is not blowing good, and this would be a problem that comes in your shop with anything. It doesn't have to be a horn. It could be a blower motor. It could be a starter motor, whatever. Here we're just using the horn.
Yeah, and another good point, let's make sure we put that in there, G. All of the electrical devices on the car work because of the current they receive. If something impacts that correct current flow, it won't work properly. We're using horns and lights tonight because you can hear them, you can see them a whole lot easier, but the principle applies to anything that's electric.
That's correct. So again, please don't feel, that you can't ask us a question. Don't be embarrassed. The only stupid question is one you don't ask. You really need to get voltage dropped down. If you get voltage dropped down, you're going to be able to diagnose and fix vehicles a lot faster and easier. So you can see here, we got a ground wire sheet that goes where?
This is actually located at the next inline harness connector for the harness for this horn. The horn is located here. This is where we're going to start our measurements. But then if we find a problem, we're going to need to isolate the circuit in sections to narrow down where that problem occurs. Again, go to places that are easy to get to. Don't reinvent the wheel. Once you find that section, you can narrow it down from there.
Yeah, and Craig, maybe you can put that old data wiring diagram so they can kind of see what it looks like and how we found the connector that's up in here, okay? And you'll see that right behind me up on the screen and as a slide. So we found out where that, I'm blind as a bat here, that ER or the GE1 is it?
Actually,
bottom
this is not unusual either. And if you've been working on
GE11.
cars,
GE11.
And
We
if you-
found that where it is.
and you've never worked on cars before, you know that oftentimes the block diagram or representations you see in most service information won't necessarily show every single connector. But we're techs, we're smart, we have a little bit of common sense. We can follow the harness and find that pretty much for ourselves, which is exactly what we did in the Hyundai's case.
And don't forget, having the proper information. The wiring diagram is the map, just like we used on the problem GM car. It is the map like you would not go without a GPS getting here, okay? And
Only
you're
backwards.
driving around. You may go to the wrong place. I remember that happened a few weeks
I
back.
never ended up in Mayopac, baby.
He'd be stuck in the Bronx somewhere. He said, boy, I seen a couple of things. We won't go there. Anyway, let's see, Pete. Here's your positive lead. We have a good ground. If we want to put power or anything to any, we could put power or ground.
Sure.
But right now he's testing with his meter.
Let's see, we're going to go to the positive side of the load first.
And by the way, we've already back probed the pins there. Carefully back probed it. We have one, you see black tape around the other end. Remember what Pete said. If you're going to back probe something, and there's those T-pins, you want to make sure when you're on a test drive, positive and negative do not touch each other or you may get a smoke show.
Yeah.
Okay?
Well,
So right now we don't have, we're on millivolts, we don't have anything. We got practically nothing. In fact, if I was on volts, if that's our hot line, shouldn't we have something? What do you guys think? Should Pete be getting something? Well,
Someone says honk the horn.
there's the person.
Didn't you say something about 000?
Yeah, it's impossible to get to 000.
That's a good sign of open circuit.
Right.
Or we have to have a circuit working for voltage drop. This circuit isn't on.
It's not on. It's like trying to test the headlights with the headlights being off.
Yeah.
Absolutely crazy.
So I wonder if we try that again, but we get our friend Rich up there to push the horn button.
Push the horn, Richie boy. Whoa, we had, do that again. 12 volts. Hold it on. 12 volts, 520 millivolts. Can you get that? So we know we got good voltage, Pete.
Yeah, that was within the half a volt of what we had at the battery.
Sure, and by the way, you want to test what the battery is?
Yeah,
I put the power probe on here. 12.66, 12 volts, 660 millivolts. What do you?
Yeah, that's what, 200 millivolts?
Yeah, less than 200 millivolts voltage drop.
Okay, so the positive side of the circuit must be pretty good.
So remember that circle? The feed side of the circle? That's all good. There's the load like the light bulb. Now the ground side, that's what the black tape is on.
Yeah, let's try that one.
And remember, we got to load it up. Always do this, guys and gals. Go to millivolts, because remember, 4 or 600. This meter has a 600 OL. When Rich loads the circuit up, if we go over, it says OL, I'm going to scale it down one scale. So let's see. Go ahead, Rich. OL, I'm bringing it down, blow it again. Hang on, yes, get back on that pin.
There we go.
Get Rich. Wow. You had 9 to 10 volts. I'm going to hit min-max and do that so you can see. So I'm going to use min-max on my meter. Do it again, Rich. I didn't see it. I don't think we got it. Hang on. Go ahead, Rich. Wow. I don't know if you're in there. We're not getting that ground.
Oh, I think the pin shifted a little bit.
Okay, hang on while we reshift again. Doing stuff live, things happen. I'm going to put min-max. Go ahead. There you go. Okay. So, oh wow, look at that. We had 5 volts, 90 millivolts voltage drop. So, Rich, we're losing a lot on that ground side.
Well, you know, there was 2 things that we saw when you use the millivolt scale technique, and when you use that, make sure that you're doing negative to negative, positive to positive, one leg at a time. You see the OL is just like saying ouch. The meter's telling you that's where the problem is. Here, using a straight reading, we got 5 volts. That's more than that half a volt we were talking about, isn't it?
Oh, way more.
Big
way
red
more.
flag.
And again, see what Pete said? We're here ground, negative to negative. This is like taking the lead and being up at the battery. The next red lead is the next negative in the circuit of the load. We're on that, and we get 5 volts voltage drop. That means we have bad resistance in that circuit.
There's a thief in there.
There's a thief there somewhere.
Now to find it, we're going to start working from the ground side of the load back all the way up to the ground side of the battery. And as we mentioned earlier, along that route is a connector that we've unplugged and set up so that we could access it easy and save time. Now I'm going to put the negative lead, or the meter lead, there.
And remember, let's remind them, once again, negative to negative, positive to the next negative, and let's see the reading we get. Rich, blow the horn again, please.
Wow, let's hit that on the millivolt scale.
Yeah. Nothing happened there.
Hit it again.
So we got like 3 point something.
Is that under the half a volt?
Way under, I would think, right?
Then we must have passed the problem.
Ah! So the problem is from here to there somewhere.
Yeah. Now I can just go back the other way a little at a time until that meter reading goes bad again and narrow down exactly where the cause is.
And by the way, there's where something like that Hirschman probe? Hirschman. Sorry, Mr. Hirschman, wherever you may be. Was that Mrs. Calabash? Well, whatever. Anyway, we could take that and carefully go along the wire until we find the problem. Well,
yeah,
we made the problem, didn't we?
Yeah, and I tell you, this guys, I know it's not high tech, but it works.
And we hope this brings the point home where if we take the tape off this light bulb, we loaded the circuit up with unwanted resistance. Rich, can you do the blow for us, please? There's the bad ground. There's the unwanted resistance. Now, again, just think of this. This is an extra load, extra resistance in the circuit, cutting down on what? Current flow.
Right.
That's a voltage drop. There's VD once again bearing its head out with a too much resistance, a load of resistance that's unwanted in the circuit. Okay. Let's see what else we got. Okay. So we want to know, Craig's going to look at some of the questions. I'm going to let Rich down. Okay. So Craig, do we have any questions? And again, here's that probe that I was saying. Can they see that in the camera, Craig?
Yes.
Okay. This is the probe that I would take little by little going across that ground to find the problem.
Someone asked, will you lose some amperage if you use if you back probe something?
Will you lose some amperage if you back probe?
Now, when you back probe a circuit or even pierce the wire, you're putting your tool in parallel.
Yeah, so
The way
you're not,
electrical circuits work, you won't impact the current flow.
yeah, you're not going to load the circuit up at all.
We have a good question. Is 500 millivolts for just one side or the combination of both sides voltage drop spec?
Well, and here's, by the way, here's Rich Peterson, one of our TST members here. Rich, you can
Go around you
just
here.
come in.
Excuse me.
Say hello to everyone out there.
How we doing? Okay.
So at any rate, thank you, Rich.
All right, excuse me.
So at any rate, 500 millivolts is the max on each side. Now again, that's really on a big circuit. That's on really, you know, when people or manufacturers publish specs, that is like the max. I've got to be honest with you. If I'm looking at a lighting circuit, I'm worried about a half a volt. Okay? I play to 200 millivolts per side, the feed side, the ground side. Now, am I going to have a baby if I have 500 millivolts on that big starter or some big circuit that has high amperage? No, because 500 millivolts is not going to make a big difference.
And you know, G, I want to ask you, and I'll even ask Rich, kind of a pointed question. We're talking about 2/10, 3/10, up to half a volt as a spec. But in the real world, when you actually have a ground-related issue, which is absolutely the more common of the two,
No doubt.
from
Ground is
corrosion
the
or
problem.
poor connections or damaged connectors, would you say that 99% of the time when you check the ground side meter reading, it is way over any of those specifications?
Drastically.
Drastically.
It will be a red flag. Don't get hemmed in on a tenth or two. If you get one that says 4/10 and the circuit's not working right, maybe that is the cause of the problem. If you get one that's reading 6/10 but everything is fine and dandy, then it's not an issue. 9 times out of 10, if you're doing a voltage drop check because of a bad ground, when you measure it on the ground side, you check the entire path, you know the circuit's operating when you test it, it's going to stand out like a bull in a china shop.
Right. And remember, the 600 or the 400 or 600 millivolts OL, I always tell everyone, take your meter and put it on millivolts. Well, UEI has a meter here, and you can see it'll tell you OFL, and the circuit is open. This is an actual function of this particular meter that does voltage drop. So if you're not sure, well, guess what? You can use a meter like this that tells you, hey, you got an open. Now, the bottom line is, Pete, we can do this with any brand meter, correct?
Absolutely.
We're not here pushing a meter. We're just here to try to make you understand what tools and equipment. Buy yourself a good meter. All of the meters we showed you tonight are good. There's other ones, okay? This one happens to do the voltage drop and tell you either it's open, big voltage drop, okay? Or you have high resistance where it says it's bad or it's good.
Right.
Okay? So that was a very good question, and we thank you.
How about computer powers and grounds? Is it a good way to test it by disconnecting the module and using a test light for a load or to measure the meter?
I personally prefer to, if you're testing for the module's grounds, test it with the module doing the work. If there's a problem in the module itself, you might miss that by replacing it with something else.
Well, let's say this as well. First of all, I always like using the real component. A test light uses about 200 to 300 milliamps. Okay? One of the things that people would do to test some of the old GM modules and stuff, the driver in the module, they would say unplug the coil, and that's the ones with the 2 pins. And if you take it out and you put your test light there, if the light flashes, you're getting the driver actually doing that. Well, guess what? There's a big difference lighting up to 200 to 300 milliamps and lighting up a coil that may take 6+ amps. So I would recommend taking alligator clips similar to this and taking a big headlight and loading it up. If it can light the big headlight up, guess what? Bingo, you got a good driver. Same with the stuff here on people put Noid lights, okay? And when people say, you know, oh, the Noid light flashed, the driver in the computer's good. No, no, no. What's the current flow? A pintle will open at about 700, little less, little more, 700 milliamps. That's almost an amp. Well, you're opening a light or making a light flash at 200 or 300 feet. I don't think you can use that. In fact,
Right.
I know you can't use that. Any other questions, Craig? While we're waiting, a great resource, ASE, Automotive Service Excellent. They have click on professional services, then prepare to take the test, then aftermarket resources. And when you go down the list here, people like Worldata, the EPA, my company, ATTS, Check Chart, of course, Motor Age, Lincoln Tech, and so on and so forth. You could see all of the aftermarket resources that can help you understand electricity a lot better. By the way, with ASE tests coming up, the Motor Age book, the A6 book, a great book for you to look at. And I'm not just saying that, okay, not because Motor Age is here. We've been using this in TST to help a lot of our members that are good technicians and sometimes a little rusty to get through passing the ASE test.
And speaking of training, I know that when I was a tech in the field working full time, we often didn't know about the training opportunities that were available to us, or some may have been a little out of range, or they were at the time of day when, hey, we've already been working all day long. And again, let me just put it aside, I really appreciate all you guys and gals hanging out with us this late. I know you put in a long day of work. But there are some other events coming up that I want to make sure you guys know about. March 26th is TST's big event. It's going to feature John Anello.
No, John Thornton.
No, John Thornton, yeah.
Vehicle Network Diagnostics with John Thornton.
Yep.
MAF and Fuel Trim with Scott Manna. Automotive Fluids, What You Don't Know About Them, with Pierre Rispo. And by the way, this will be simulcast the whole day from 8 o'clock to 6 o'clock at night. The simulcast will start. March 29th, a webcast with P10 on electrical and scan tool, so you can look forward for other stuff. March 30th, turning green into ROI, return on investment, Motor Age. And is this the one that our buddy is doing, Nick Schneider?
No, this was the AMI.
AMI?
But that is a good point. Let me just kind of throw that in real quick, guys. Every Wednesday at 1 p.m. Eastern Standard Time, Mitch Schneider hosts his own live web video cast. MotorAge.com/Mitch. It's just like this, live, interactive. If you own a shop, if you aspire to own a shop, Mitch has got a just wealth of experience that he's sharing, and all it's going to take is some of your time. Join Mitch every day, Wednesday at 1 p.m. Take your lunch break and ask him questions. Find out what he always got. Pick his brain.
And by the way, he does great management classes. So what he's doing for Motor Age is bringing it to you at no charge.
At no charge.
So make sure you understand that. April 7th, that is EVAP with Bob Pattengale, the whole shebang on EVAP.
And Bob Pattendale, he's with Bosch.
He's the Bosch man.
Yeah.
And then after that, we got our buddy Dave Crippen, Drive Case Studies on May 5th. And again, these are all simulcasted. Dave Crippen, guess who he works for? Bosch. This must be a whole bunch of Bosch guys. No, sometimes that just happens. And May 26th.
Oh, I get to come back up here again.
You come back to New York. Maybe he gets a little sunshine and a little heat. That's on May 26th. Usually gets a little warmer around here. And that'll be AC Best Practices. And again, you can get that at motorage.com or tstseminars.org.
Yeah.
Look for our email blast going out. Read everything on searchautoparts.com and Motor Age.
Yeah, don't forget, the same place you signed up for tonight's video cast, you can sign up for all the ones that we're offering for 2011 if you choose to do so.
And we'll give ourselves a shameless plug here. TST is a 501c3, non-for-profit, education approved. We've had great instructors, like I don't know if Ralphie Boy Birnbaum is still out there. We've had people like him and Ralph. Maybe we can get you back to do one, okay? We've had people like Don Schnell, John Thornton, you name the guys, John Thompson, Bernie Thompson, who?
Mark Warren.
Mark Warren, we even had him. We have had just about every great instructor in the country to come out. This is our 8th year big event. We were part of SAE, Society of Automotive Engineers. We took over from SDS. It's a good cause We appreciate all your help. Someone like Alan Boggs, I know you're out there down in Louisiana. We appreciate you always coming on. And Craig, flip the next slide. So there's tstseminars.org. Right here in the training center, ATTS, if you're interested in hands-on training programs, we provide training to a lot of different states and the EPA. If you're interested, let me know, and we'll be more than glad to give you a price quote or whatever. What else do we have coming up?
I think that's the last.
I think that's it.
Any other questions?
So we're here for questions, because Pete has nowhere to go but that damn hotel. So guess what? You know, it's pretty early back this way yet for at least me. I usually do classes
Okay, we
late.
got a few questions.
Good. Let's handle those questions.
What dielectric grease do you prefer to help prevent corrosion? I work on a lot of plows.
Is it referring to brand? I think it matters as far as brand goes. I understand what you're saying. A lot of the connectors that are exposed to the elements. I know a lot of guys will apply a small dab, then plug the connectors back together. As they do so, that forces the grease out from the inside of the connector, allows the connection, and also provides some form of seal.
But we got to be careful on using dielectric grease. You don't want to use that on an oxygen sensor circuit,
Right.
because the oxygen sensor circuit has one of the wires that actually is sensing the outside air. So greasing that up, you ain't cleaning that out afterwards. But for light bulbs, certain connectors,
Trailer connections.
dielectric grease, plows, yeah, you can use dielectric grease. I think whether you buy it from the red guy, the blue guy, the purple guy, or the yellow guy, they're all the same.
Yeah.
You know, high quality, buy something good. Try to buy made in USA, so we have some jobs here in the US, by the way. Okay?
Do connectors add a bit of resistance?
Oh, definitely.
Sure.
The more connectors, Pete and I can tell you,
Sure.
the more resistance. Now,
But you're going to find that the resistance is almost unable to be read. Especially
if they're
with
good connectors.
Right. Especially if you're using like a standard ohm meter that you're used to, it's just not going to measure that resistance. That's what you saw earlier when we gave you the specifications. That's why you're never going to have a perfect zero throughout the path of the circuit. And that's why. It's all these little connections along the line, the copper wiring itself, all of that has a measure of resistance.
Sure. You know, if you look back to one of our TST things, the one Rich and I did with ASE, we have a case study that was on that Volkswagen that I mentioned earlier. That little, and this is common on Volkswagens, you'll melt the fuse box.
Absolutely.
There's a voltage drop in this much, no exaggeration. It's right there at the terminal. It's okay to have 200 millivolts if it was from here to there, but not there.
Certainly.
Okay? Not that close. Okay?
It was one of them was actually the crimp itself. The insulation was not stripped off the
Strip
wire.
off. And that's another problem. A lot of times these companies don't strip off. So we only have a few minutes left, Craig is telling us, because of archiving this. So
We'll be quick.
we'll be quick.
We'll be
Let's
real
answer them
quick.
all.
Let me just try one more thing here then. Guys, this is live. It's been a real pleasure to be up here with the gang at TST for the very first Motor Age TST webcast. If you do have any other questions, like I said, tomorrow morning I'll have a message board set up related to our class. Feel free to post as many as you wish. We will get to them all. And then as soon as we get the material up, say 48 hours or so, you'll be able to review exactly what we've done tonight over and over and over again. Again, G, I really appreciate you guys helping us out with this. I hope that you guys and gals got some benefit out of it. Let us know what you thought and what you'd like to see.
And we thank you, Pete, and Motor Age. We're looking forward to doing a whole bunch more with it. And thank you, most of all, out there, because without you, we wouldn't be doing it.
That's right.
Hopefully we helped you. Good night.